Okay, welcome to this session about Azure API Management in the Azure User Group Norway. Today's agenda is most about what is Azure API Management actually, and how we can get started with it. I will touch on the concept and also dive a little bit into what it can do using examples and a simple demo application I have running. And we'll also try to find out what the next step is if you want to get going with API management on your own. My name is Anders Eide. I'm working as a manager at KPMG, and I'm also an Azure MVP. And you can find me online mostly with the handle you can see here, Anders Eide, and I'm also available on email if that's your preferred channel. Yeah, what is API management? If you have questions during the session, feel free to just unmute and ask. But basically, API management is a place where you can manage your APIs. So it's not a platform that hosts APIs. It's just a platform that enables you to handle a lot of the logic around making APIs available, what policies should be on them, and so on in one service, and let the backend handle the logic which is behind the API. It's also a platform as a service, so it scales as needed, and you can also put up auto scaling on most of the tiers. We will look more into that as we go along. And it's also great to do testing on APIs, so you can mock up and try out the APIs before it's published to your developers. It's also a platform which can secure and optimize APIs. So for example, you can say that you have to use a subscription key to get access to the IPA, and you can also configure like IP control, check which IPs the applications is coming from, and you can also do token validation. So you can actually integrate this to, for example, Azure AD, Facebook, whatever, to verify that the requester has the right keys to actually access the API. It's also great to get insight to what's happening in your API. So it's integrated with application insights, which I also will show a demo of. And you can also there look at what the backend actually did during the request, what kind of data was sent back and forth during the communication. And finally, you can connect it to about anything. So as long as the backend is accessible over internet on HTTPS, for example, or even on private networks, if you go into the premium tier, you can basically use API management to make it available and secured worldwide and scalable as you grow. So it comes in a good set of flavors. The consumption tier is the newest one, which is more aligned to the serverless world, where you pay as you go and only for what you are using. There has some limits compared to the other ones, but as a startup, it's perfect because you don't have to do the initial commitment on a quite high monthly price for the other ones. You have the developer version, which has about everything, but it's also limited on SLA, and it also has some limits on how many requests it can handle per second. But it's great to use it when you're going to test stuff, and that's also the version that we are going to use in the demos today. And then you have additional tiers with different limits, but they are all mostly in the cases I've been working. It's good enough with basic and standard. Premium is when you have really specific use cases. there is a lot of terminology that we have to go through. And if it's the first time you're working with API management, some of them can be a bit difficult to handle in the beginning. At least I felt so. But you have this backend API. This is what the API management service is sending the request to after it's been processed in the service. And then you have the front end, which is what the application will hit the first time it comes to the API management instance. Then you have the products, which will define how the API is, for example, going to operate depending on the subscription level. So for example, a product could be free product, the standard product or premium project, and you can have different policies on each one of them. And they have the operations, which is the process itself within API management. I have a graphic which will show this afterwards, but basically you have the operations is what's going to happen from the front end through the processing on inbound, hitting the back end and outbound processing and back to the application. You have versioning possibilities, so you can have different versions of your API, which is great when you continue to develop something. You can have different versions from, for example, the primary, which is version 1 or current maybe. Then you can have a beta version of the same API easily available within the same service. And you have the developer portal, which is available only in the which is not available in the consumption version, but it's a portal where developers can log in and test your APIs before they actually go and buy them. And that's also both for internal and external. And then you have policies, which is a really important part of API management. This is the thing that actually controls that your API is operating as it should be. Define, for example, IP control, checking if a user is authenticated, and also transforming the headers, for example, or the content, if that's necessary during the request. So let's start with the API gateway, which is one of the key concepts, which is really important to understand. And this is the service that accepts all API calls and handles them, controls them, and routes them to the backends, and also are sending the response back to the application. And this is where you can also configure different policy levels, and you can also configure, for example, caching in the gateway, which is great for application or APIs, which is not changing that often on the response. This is also the service that logs everything which is going on during a request. So it works like this graphic. So you have somebody requesting something in the API, which will then hit the front end. And the front end will then decide on the inbound processing where and what is going to be sent to the backend. And when it hits the backend will send it to the service which is actually processing the request. So that could be, for example, an Azure function. It could be a Logic app. It could be basically any API or web HTTP endpoint out there on the internet. So it could be an application you're developing yourself, or it could be even Microsoft Graph, for example. And then when it's finished processing, it's sent back to the backend, and the backend is doing outbound processing through the front end again and back to the application. Did that make sense? Any questions thus far? Just feel free to shout out. If not, I will just continue with the next concepts, which is the Azure portal and the developer portal. The Azure portal is where you will be defining and configuring the APIs. And you can also package APIs into products in this portal and make it available into the developer portal. This is where you also configure policies and can manage user subscriptions and so on. Most of your work will be going on in the Azure portal, at least in the beginning. You can also configure everything in API management using, for example, PowerShell, or just directly using REST or even ARM templates. But that's I think that's a quite advanced topic. Then you had developer portal, which is, as mentioned, not available in the consumption plan, but it's a place where developers, internal or external, can go in and read the documentation you have written for the API. They can also try it in the console and configure subscriptions to the APIs to get the subscription key, if that's one of the requirements for the product. And you can also access some analytics data, so they can also check what is going on with their own API application. So the key concept of API management is then that you have some kind of API with operations configured. And API management can have multiple APIs and operations. On the operations level, you have an option to configure policy, and you have also an option to configure policy on the API itself. And when you have configured that into a product, which also have policies, that's about everything you need to be able to make the application communicate with the API. So the product which will make the API publicly available and everyone can use it without any additional configuration. Or you can decide that you have to have a subscription to be able to use this product. If you configure this, the application must have a subscription key to be able to access the API. So this is everything which is in the consumption plan of API management. In the other plans, you also have the concept of users and groups, which enables users to sign up and be a member of a group to get access to different subscriptions. So if you're not a member of a group which has access to the premium subscription, for example, you won't get that up in the developer portal. So when a user is a member of a group that has access to the subscription, the user can sign up for that one, request a subscription key, and make that available for the application. And then finally, you have the global policy, which is the top level policy on the API management instance. So a policy, I want to just highlight the policies a little bit more, because that's a really important part of API management. You have 4 different levels, and all the levels will be processed when a request comes in. So you have the global scope, which is for the whole API management instance. You have the product scope, which will be configured to just trigger on the products that the subscription are attached to. Then you have the API scope, which is common for the whole API group, and you have the operation scope. So you can actually configure a different policy on each operation, which is going to happen within API management. And then you also have this concept of a base element. So the base element of the operation scope will inherit the policies configured for the API scope, and the base policy for the API scope will inherit the product scope policies, and the product scope will again inherit global scope. And the global scope doesn't have a base element because, yeah, it's on the top, right? So with this in mind, you can actually configure quite advanced policy sets for your API and basically do anything within API management, and don't have to think about the API logic within your API management and API access logic within your backend service anymore. You can just handle that in API management instead. This is the demo which we'll be working on the rest of the session mostly. And it's a simple application I built last fall before I had a presentation at IT Dev Connections. So it's basically a static website running in Azure which access these API servers, and it's a word cloud application. So it's a service where users can log into a cloud and vote for a word, and you get a nice looking word cloud out in Power BI, which I see I have forgotten to start it. So I will bring that up in a second. Actually, I think I have it within Teams. Let's see, yep. This one. So this one is basically a Power BI application, which is leveraging the backends through API management service. So when I pull a new cloud, this is what I get, and I can do filtering in Power BI. This could also be a website, but I'm not a good enough developer to have written this in web yet. So that's my next project, I guess. But if we dive in a little bit on this one, I want to show you how API management has been configured for this specific case. So within API management, this is a portal, by the way. When you provisioned API management, this is what you get, and you can go in APIs and begin configuring. So I have two different versions for this one, and this is all the operations in my API. So for example, if we go to get cloud, you can see that this is basically just a front end with a defined path and a URL template, which I bring with me into the inbound processing, which is also pulling this part out from the URL and sending it to a logic app. The logic app is processing the request and response back to the service. So if we look at this logic app, which is within this resource group, get word cloud, it's actually just a logic app with an HTTP request action, and it pulls out the cloud ID and gets that data from Azure storage table and responds back to the request. So when this is finished, it goes back into the outbound processing through the front end and back to the application. And then you have the post vote. I will actually show you this one afterwards. You have, this one, post vote. It's the same thing. It has a front end which accepts post. It does some logic on it and sends it to the back end, and then back to the front end and to the application. So if I go to word cloud here, which is a really simple website, I can just type 123 123. And if we look at the console and network processing, when we are doing that, I can do it one more time. You can see that a request is sent to my API management instance with the path for this request. So get cloud, and back I get the information processed in the logic app. So response, you can see I get the cloud ID and a lot of more information, everything processed within this logic app. And then I can vote, for example, fun, submit the vote. And you can see that it's real simple headers and there's really simple post sent to the API management service, which hits this other logic app. So post word vote, and you can see it was just processed seconds ago. And this one is just putting the message to a queue, and another logic app will pick up from that queue and have fun. So I can see actually someone in the call is also testing this out. So I didn't type Rosenborg for sure. I did fun. But we should be able also to see this in Teams quite soon, that it's coming in here. So if we refresh this one, come on. Yeah, it should be here in any second. So because I have a logic app processing the queue, I think it's every 10 seconds or something. So read word queue, it's been read, so it should be in the cloud quite soon. But anyway, that's another demo, and I can try to get it working afterwards. But if we go and look a little bit at the policies, we can begin with the global policy, because I think that's a quite important thing. And you have that one on all APIs. I have not configured any policies for the global scope on this one. So it's just forwarding the request to the backend. That's all it does. Then you have the product scope for the world cloud. So if I bring up here, I can look at the policies. And also here, I have not configured anything, but I could do policies here for the whole product. For example, I could say that in the Word Cloud free edition, which does not require a subscription, I could say that you're only allowed to, for example, send 10 requests each second. And then I could create a Word Cloud premium version and also configure that it requires a subscription. And the policy would be that you could, for example, publish 100 posts each second. And then you have the API scope on version 1, all operations. If you look at the policies here, I have some more. For example, that I can access this from anywhere. I don't have configured any specific course rules for it. And I also have some outbound policies, which is stripping off some of the headers coming from the Logic app, just because it's not necessary to have information about the backend service out on the client application again. And then on the operation itself, the inbound processing, for example, I have a lot of stuff going on. So I'm, for example, saying that the cloud ID is going to be picked up from the request and sent as a query parameter instead to the backend service, which is then picked up by the logic app and processed. And the same thing with the post. You can see that I'm not doing that much, but you can see that you're also pointing the request to the backend service instead. So that's actually configured in the policy for this operation. Any questions this far? Feel free to shout out. Now you can unmute if you want to. No? Okay, I'll just continue then. So that's the policy part of this. The subscription thing is also quite important, at least when you have application that's going to be protected. So in this Work Cloud 2 version, I've begun configuring the API to actually require a subscription. So you can see on the settings page for this one that the products is configured to be Word Cloud 2. So going back to the product for Word Cloud 2, you see that it requires a subscription and it requires an approval to be able to get a subscription for it. When you have a subscription signed up, you can also go here and enable it and activate rather. So when somebody signs up using the developer portal, you have to go in here afterwards and activate it. And when that's in place, the developer can go ahead and actually request a subscription, which will give you a key for accessing the API. And the developer portal looks like this. When you access this from the Azure portal, you actually sign in with an Azure credential. So you get administrator access straight away. But from here, you can actually go ahead and look at the API information, which is written in the API service. So for version 1 here on Get Cloud, you can see that I have configured a description, so I can enhance this one. So using this API operation, you will access cloud and save it. And back in the developer portal, you can see that the documentation has been updated for this specific API. So before you put this into your application, you can actually go and test it. So try it out. And Cloud ID is one of the required parameters. So 1, 2, 3, 1, 2, 3, 1, 2, 3, send. And you can actually see that it's working. You can see which kind of response you get, and all the information. So you can test the API without using, for example, Postman, or actually have to put it into an application. And then the same thing with post vote. You can go ahead and try it. So in this one, I would have to write out the request completely. So I can just go ahead and copy the one from the demo, paste it in, fun for real, and send it, and see that it actually works. So the developer portal is not available in the consumption tier, but if you have the developer tier, I find it quite useful to debug and test API before I put it out in production. For tracing, I have in this case configured application insights. So all requests sent to the WordCloud app, WordCloud API is also logged into into application insight. So if I bring it up, let's see, application insight. Just have to find the right one. I can go here and look at all the requests sent to this API. So this is logged instantly from API management. So for example, I can see here that it was that the vote was received and it was sent to the backend service. I can also go in and see information about the response type, body, and also what the request was, and yeah, a lot of more information about the operation and activity itself. And if something fails, I can also get that one in API management. But I built this application quite fail-safe, so I don't have a failed example available. I could, for example, now I don't have I'm not able to fail it. Anyway, back to the is questions, by the way, about this one? If not, I can just show a little bit about how it's configured.
Sorry, one question.
Yeah.
Do you see the client and IP address in this requests history?
If I can see the IP and information about the request, yeah, you can. So at least you should be able to see it somewhere. Yeah, you can see at least Netherlands and Amsterdam. Client IP is blank, by the way. I'm not sure why. But yeah, you should be able to get a lot of information out. And you can also configure to get even more information in the policies. So in the policy settings for an operational API, you can build in your own auditing and logging information if you want to put out even more than what's sent directly to application insights from the service.
And one more question: if I will create test my requests from the developer portal, which source IP will be if I, for example, if I create the policy and restrict access only from one IP address, can I create a test request from the developer portal?
No, you can't. So the developer portal will be working just as an application. So for example, in developer portal, if you have configured that you have to have a subscription or you have to have a valid token to actually use the API, it will fail if those requirements isn't set. So the developer portal is basically an application which can access the APIs on the same level that that the applications you would use in real life would. So, for example, if I bring up an API where I have configured that they have to have a valid token, I think I have that for the Office 365 automation. Yeah, this one. I have an API saying that they have to be authorized to use it. I think I have that on this demo one also. If I try this one and send a request without being authorized, let's see, it should fail quite fast. Yeah, unauthorized.
But this request is going from your local workstation, or it's going from the application gateway. Where is?
Oh yeah, sorry. Yeah, it's coming. It's coming from my workstation.
Mm-hmm.
Yeah.
Okay.
So I'm pretty sure it does. At least let's see. You can try it. So looking at the network traffic and send, you can see the query is coming directly from me.
Got it. Thanks.
Yeah. And then if I go and log in, I get the token from Azure AD and send it. And you can see that the workflow actually triggered on the backend, just saying hello world. So this is another policy which is quite common to implement early when you're using API management, at least for Office 365 automation. And it's a really simple policy, which takes a lot of time to implement in an application. If you would write the API in something else than API management. So while looking at this one, I think I have configured this policy on the operation itself. Yeah, validate GVT. So let's see if I can bring this up in a little bit better screen. Expand it. So you can see it's a lot of logic going on. So it's checking that, if I can find the control GVT, this one, it's validating the GVT. So it's just checking that it has a valid token issued by the application in Azure AD, and it's checking it towards my own directory. So as long as it the authorization header has a GVT token issued and validated by Azure AD, I'm granted access to the application. And then I remove the authorization header before it's being sent to the backend service, because I don't want that information sent back. So that's also a way to configure policies. And I've configured this on the operation itself, which means that you can have different, for example, you can have different token issuers for each operation. We can have one on the same for all operations, and you can also configure this on products and also the API management service itself on the top level scope. So it's a high flexibility. So that's just a quick overview of API management. And if I want to change this one, I can basically do a copy of my current version, do the configuration, and switch my application to use it. So that's one of the way to monitor and not monitor, but control which API is available. But you also have the concept of revisions. So it's quite flexible on how to actually do change. So if I bring this up to full screen again, I can go here and see which revision is configured at the moment, but I can also go and create a new revision, for example, for this post vote. So by adding a new revision and, for example, trying out some new fancy policy, great. I will have a new revision on the current version of the API. And I can go ahead and test this revision by just adding rev2 in my request. So this is a private URL now for that version. So I can go ahead and in the design post vote, just make sure that's saying revision 2. Then I can go in here and try, for example, something else. I can say that this is going to be a mockup instead. So mock response on every request with a 200 status code, and content type is application JSON. And then I can go and configure the front end and say that when I have a 200 response, I can also just say that it's going to on application JSON have a message saying hello and save it. Just got the feeling that I had a typo in. No, that's right. So bring a postman, for example. I should be able to create a new request and say post. And instead of doing it towards the normal endpoint for this one, I can have the revision 2. And in Postman, send it. You can see that I get a mocked response instead. So that's some of the flexibility. So when I'm happy with a revision, I can go ahead and make that revision the current version instead, and have then upgraded the API within API management service without breaking the applications in front. Of course, if I make this current now, I will break it, but you can actually go ahead and test without actually breaking something. And instead of maybe doing a mockup, I could actually go ahead and change which backend I'm hitting. So you can actually then build a completely new backend for that operation, test it in a revision, and then make it public for end users. So it's a quite powerful feature. Any more questions? Oh, okay. Also, named values is quite important thing, especially when you're going to maybe have both a production version and a developer version of API management, because then you can use named values as variables. So in you can then write the same API configuration on both dev and test, and use named values to change the details. So a named value can be everything from a it's basically a string, and you can make it either secret or not secret. And to reference it in the API, you can go ahead and can show it on this one. Use this format here, so you can see that it's getting its signature for the backend logic app by using a name value. And this is the secret logic app are using when you're having a HTTP trigger on it. So that's just one example. Or even in when you're using a GVT validation, you could, for example, put about the tenant information in the config URL in name operation, and you can also put the value for the audience in a named value. Then it's way simpler to move configuration back and forth between production and development. So it's a lot of use cases there. Yeah, I think we can continue a little bit. So a few typical low-hanging use cases for API management is often of Microsoft 365 automation. In many cases, you want to create an API which can automate stuff in Azure AD, and then it's in Microsoft 365, and it's important to have that validated, audited, and also secured by Azure AD. Then API management is great to get that in place, because it's basically enough to have just these lines to secure your API, and then you don't have to think about that in your logic apps or your functions. Then you can just say that if this workflow or this function is going to run, the request has to come from a specific IP, which is fairly easy to configure both for functions and logic apps, and then point it to the virtual IP for the API management service. And this is at least in the private versions on the developer and so on, this is a public IP which is unique for this instance, and it will not change unless the instance for some reason stops or is moved or is deleted and recreated. And basically that happens if, for example, the subscription, Azure subscription is suspended. For example, it's not paid for something and it's locked, then this IP will disappear and be created again when the subscription is opened. It's an IP which changes not that often, and you can at least control it if it does. That's one use case. And also in SharePoint Web Parts, it's great. It's easy to get an application, a token from Azure AD from a web part in SharePoint, and then use that one in API management. Also Teams application, it's great service and easy to integrate with any web application and also Teams application, because they are basically a web application. And yeah, just to summarize, if you're building an API, in any case, API management will ease the process of making it available and secure for application and end users. So that's the rule, basically. If you create an API, evaluate if API management services is worth it to secure and protect, because it's really easy to get it up and running, and it gives you a lot of value really fast. So yeah, I did mention Teams. Teams is a highly extendable platform. So for example, all tabs is basically a web application. Bots is communicating with web APIs, and the same is true with connectors and all personal apps and messaging extensions configured in Teams. So Teams is one of my favorite applications at the moment for extensibility. And I would say that as soon as you build anything within Teams, which is going to hit a web endpoint, API management could be a rescuer to speed up the process of securing and protecting the operations happening within that Teams application. So for example, if you have a Teams bot that will create new teams or going to handle some business logic within Microsoft 365, a good case would be that that bot or web app first hits web API management and pushes the operation to, for example, Logic Apps, which is communicating with Microsoft Graph and so on, and then sends the request back to Teams. Any questions before we begin looking at the different ways to do administration of API management? No? Okay. As mentioned, Azure Portal will be, most likely will be your first meeting with API management. And it's quite, I think it's a good way to configure even in production, because it's way simpler to do stuff in the portal than it is using REST API or Resource Manager or even PowerShell. Because I think the API and PowerShell commands to manage API management isn't that good yet. It's a lot of different things connected together. Just saw, for example, the drawing of all the moving parts within a request. So all of these would have to be managed and put together before you do deployment to API management. So it's just simpler to do it directly in the portal. So in most projects, I've seen that this API management service is managed manually directly in the portal, and not that often through a CI or a CD pipeline. So I think you will be working on a quite huge project before you see all this configuration be done in code. But the PowerShell module is great for example, pulling out documentation. So I can just show that one. And the easiest way to get started is just using the Cloud Console for Azure. Which is obviously not loading. Oh, there it is. So I'm just going to first check that I'm in the right subscription. Get Azure. No, I'm not. So get Azure subscription. And this one is running in this one. Copy. And the command to get information about the services is get Azure API Management. So I have to put this one into a context. So API context equals get Azure API Management context. I believed. Actually, I will just bring up a script. Let's see. Sorry about this one. What's this? There it is. So the first thing you have to do is actually define which service you're going to connect to. And this is a little bit messy script, but yeah, you have to first say which context you're going to be in. And that one is configured here. So new Azure API Management context, new is it? Okay, sorry about that one. Then you have to define which resource group it is in and the service name. And from there, you can basically get what information you want about it. So let's use this one, and it's not the right service. It's that's the right name. So I'm just going to copy this one. And then I can finally begin to use the commands in Azure. So this one will then bring out all the information about my API management instance, all the APIs defined in it, and so on. And the same thing with getting information about the specific APIs. So get Azure API Management has a lot of different commands. For example, API, which releases is available, which revisions are available, and so on. And you have the same set of commands with the set API management service. So that's one of the ways you can script things into API management. But personally, I'm just more fan of doing it in the portal because it's quite fast and it's not that often you do changes on an API. Any more questions? I see that we are closing in on the defined time for this meeting. Is there anything on the chat? Like so. I'm actually not sure. I think it's maybe only HTTP. At least it has to go over HTTP. But that's definitely something you can check out, Henrik, and get back to you on. I've only used it with the HTTP at least. And it's, of course, it's not the only service you'll be using in more advanced applications, but at least for APIs that are going to be accessed using HTTP, is a great service. But I will definitely check out that question, Henrik, and get back to you on it. Anything else? We can definitely have an open discussion the last few minutes. Feel free to unmute if you want to say it instead of write it. Well, if not, I think I'll just stop the recording, and I will definitely stay in this meeting a few minutes more, just if somebody wants to discuss something without being recorded. And yeah, apart from that, thank you.